this might be the best way to run a local Kubernetes cluster or a temporary Kubernetes cluster meant for testing. Maybe it's not. It really depends on a use case. We'll discuss that at the very end. For now, let's see what that something is and how we can use it, and go through some demo, discuss the pros and cons, and then make a decision. Should you use this to run your local Kubernetes cluster? Today we are going to discuss K3s. Or actually, we're not going to talk much about K3s. We are going to talk about K3d, which is K3s running in a Docker container or in a container. So what is K3s? Let's start from there. K3s is a lightweight, very, very lightweight Kubernetes distribution made by Rancher. And Rancher is an awesome company. Why is it important for K3s to be lightweight? The answer lies in the destination, in the places where it is typically running. And those places are usually IoT or Internet of Things and edge computing. And those devices do not have as much power as typical servers, so it is extremely important that K3s is lightweight, and it indeed is. It is almost full Kubernetes functionality, but shrinked to a size that makes sense for devices like that. And that might be very important when we are talking about local Kubernetes clusters, because you probably do not want to run a local Kubernetes cluster that will eat 8 gigabytes of your memory before it even starts doing something, or before you even deploy your application. So being lightweight is important for IoT and edge computing, but it might be very important for your laptop as well. So we got K3d, which is a variation of K3s, or to be more precise, it is K3s running in a container. And then we can run those containers locally to create a cluster that could be one node or more nodes. We can have one cluster, more clusters, and so on and so forth. We're going to see that in action in a second. But before we proceed, let me explain why am I talking about K3d now and not maybe half a year ago. And the reason why I'm talking about it right now is because recently, few months ago only, it got a config file. And for me, defining a cluster, doesn't matter whether it's a local cluster or a remote cluster or whatever it is, I need a config file. I do not want to remember all the arguments and stuff like that. So K3d got a config file, I think somewhere in January or February, I think in 2021. And now that becomes very, very interesting solution, and potentially a better solution than the one I showed you a while ago, the one about kind. If you haven't seen the video about kind, stop this one, go, the link is above my head, check it out. That was my recommendation for running local Kubernetes clusters until now. Or maybe it will continue being my recommendation. We don't know yet. We're going to see that at the end. For now, check out kind if you didn't, because it's good to compare it with K3d. It has a lot of similarities, but some things are different. Anyways, check it out and then come back here. Are you back? Do you understand how kind works? Now let's go into the hands-on part and explore K3d in 20 minutes or less. And once we do that, we're going to discuss it and we're going to choose whether you will use it or not. And if you will use it, whether it will cover all your needs or some of your needs, whether it's only for... We'll discuss things at the end. For now, let's go into the hands-on part and see how that thing works. Let's start with the setup. What do you need to run K3s on your laptop or somewhere else? Or to be more precise, what do you need to run K3d? Which package is K3s? And it's fairly simple. You need two things. You need the ability to run containers. If you're using macOS or Windows, you can use Docker Desktop. If you're using Linux or Windows with WSL, then you can use just Docker without desktop. Anyways, you need the ability to run containers, and probably the easiest way to run containers locally or in temporary clusters is with Docker. It's not a good option for real Kubernetes clusters. Actually, it's a horrible option for running containers in Kubernetes clusters, especially production. If you don't understand why I'm saying that, check out the Kaneko video, it's above. Anyways, for local usage and for temporary clusters, Docker is a great solution to run containers, and that's what you need. Now, apart from Docker, you need K3d CLI. You can install it, and the link with instructions how to install the CLI, and all the other commands that I will run today is in the description of this video. So go to the description of this video and you will find the gist with all the commands. All my videos that I made in last, I don't know how many months, contain a gist. This one is no exception. Now let's create the first cluster with K3d and see how that works. So I'm going to execute K3d cluster create. And I'm going to give it some name like my cluster, right? And let's see how much it takes to create a cluster, right? Probably a couple of minutes. Is that what you're guessing? Or maybe a minute? No, look at it. It's coming. It's over there, almost there. Yes, that's it. The cluster was created. It's finished. And it took, I don't know how much it took, probably like 5 seconds, 10 seconds. It's lightning fast. It's the fastest thing I've ever seen, at least when running local Kubernetes cluster. That's a good thing. Now, to confirm that this is a cluster running as a container, we can do docker container ls. We can see that there are two containers over there. The latter one is K3s. That's actually the cluster. And there is a proxy over here, the first container, at least in my case, which will proxy the requests entering into Docker and going into that cluster. It will just do the proxying. Think of it as external load balancer thingy, something similar to it. Now, the good thing about this is that ingress is already baked in. It is using traffic, which might be a good thing or a bad thing. We are going to discuss that later. But for now, having a proxy and ingress capabilities baked into local Kubernetes cluster is awesome. Because, hey, we need to access those things, and port forward is just horrible command which everybody uses, and I don't really understand why. Now let's take a look at the pods. What did we get? kubectl get pods -a, and we can see the system is running, right? For now, just think of this as being everything that you really need to run your Kubernetes cluster, or it might not be everything you need. We'll discuss it later. And similarly, we can do kubectl get nodes, and we can see that there is only one node, which is good for majority of us in majority of cases, but it might not be what we always need. Sometimes we might need more nodes, or sometimes we might need more clusters. So let's start with the latter case. We can create any number of clusters, and the limitation around resources, and how much memory and CPU you have in your machine. But since this is lightweight, more lightweight than anything, you will be able to squeeze more clusters than you would be able to do with Kind, or especially with Minikube and so on and so forth. So if we would like to create a second cluster, we could execute the same command, or almost the same command. So let's do it. K3d cluster create, and then I'm going to, how am I going to call it? Another cluster. That's creative, right? And we can specify a different image. We can say, hey, for this cluster, I do not want the default Kubernetes version. I want to be more specific so that it is closer to what I might be running in production. So we can specify an image, and that image will be Rancher, and then K3s. And we're going to choose, let's say, Kubernetes 120, right? That would be version 120. And I think that this is the latest one, K3s1. You would need to check the images to see what exact version you want. I did that in advance. And then we create a second cluster, just like that. And look how fast. This time it will take a bit more time because it needs to pull the images. And there it goes. It pulled the image. That's only the first time, and now it creates a cluster. It should take 5 seconds or something like that. And there we are. It's finished. I mean, it is trying to find the IP, and now it is finished. That's fast. That's lightning fast. And I like speed. I do not want to waste my time. I like things to happen within seconds or within hours. If it's within hours, then at least I can go to Cine or watch a movie or something like that. The worst case scenario is when it takes 15 minutes and then you cannot do something interesting and you get bored to death. And now if we list the containers, docker container ls, we can see that we have 4 containers. Now, 2 containers that represent 2 clusters and 2 containers that represent proxies into those 2 clusters. But there's more to it. We might want to create a configuration file, but before we do that, let's see how we can delete those 2 clusters and start over in a slightly better way. So the command is K3d cluster delete, and then the name. What is the name? My cluster, I think, was the first one. There we are, deleted within a second. It's extremely fast. And then let's do the same thing for the second cluster. K3d cluster, delete, and the second name was another cluster, I think. There we are, it's gone, it disappeared, and my resources are freed for something else in case I need them. We can execute commands like the ones I showed you, create a cluster when we need it, destroy the cluster when we don't. But a better way to do things is to create a config file, store it in a repository of the project we are working on, and then we create a cluster depending on a configuration file. So a cluster is always as we want it to be without trying to figure out what are the additional arguments we might need to specify or we might not need to specify. Anyways, let's see how we can use a configuration file, and to make it more interesting, we're going to create a bigger cluster with more nodes and a few other things. So let's explore that for a second. And that configuration file is in a Git repository, and I'm going to clone it. https github.com/vfarsik. And what is the name of the repo? I think it's K3d demo.git. There we are. We got the repository. I'm going to go there. Excellent. Now let's take a look at the config file I'm going to use today. And it says, hey, you know what? This is a simple type of cluster. There will be more complicated later on. I think that this is the only one currently available. The API version. The name of the cluster is going to be called my cluster. The image, which effectively says which version of Kubernetes we want to run in this cluster, so that you don't need to remember -- image, this and that. How many servers do we want? 3 servers. This is going to be a bigger cluster, and 3 agents. Servers are effectively control planes and agents are worker nodes. And the ports we want to open, 8080 on both sides. We're going to enable load balancer over there. And I have a few other options that I commented. We're not going to go through them right now. I just wanted to show you that there could be additional options and options and options, right? This particular one that is commented would be in case we do not want to use traffic as ingress, and we're going to discuss that later. So now to create a cluster, the command would be K3d cluster create, and then we say config, and the path to the config file, which is this one. There we are. It should be go. 5 seconds, 4 seconds, 6 seconds. I don't know how long it takes. It shouldn't take long. Actually, it will take a bit longer than usual because it needs to create 6 nodes, 3 for control plane, 3 for worker nodes. And while we're waiting, why don't you subscribe to this channel and click the like button? If you got to this part in a video, you probably like it. You would give up earlier. So click the like button and subscribe if you haven't already. It's slow. I'm disappointed. You'll see it's still faster than using any other type to create multi-node clusters, but it takes a while longer. So let's fast forward to the end of the process. There we are, we got the cluster. We can do kubectl get nodes and see what's inside of that cluster. Well, how many nodes do we have? And we can see here that it's 6 nodes. 3 are for control plane, and then etcd and master. Actually, it's misleading. It's not etcd. K3s is not using etcd, but we're going to discuss that later as well. Anyways, 3 for control plane and 3 for worker nodes. And that's our cluster in this specific case, right? And now I do not need to worry about how big of a cluster I should create, what it should have, what it shouldn't. I can just put a config file, a YAML file in each repository I work with, and then create whatever is defined there. Now, to be honest, that's not specific to K3d. You can do the same thing with kind. You can do the same thing with the Minikube. But still, it's awesome. And K3d didn't have it until a few months ago, so that's why I didn't use it until recently. Finally, let's confirm that we can actually use this cluster, not only create it. And I'm going to deploy something with kubectl apply -- file name, and then the address is K3s. This is the directory that contains definitions that I prepared a small demo. And you see it created it, and let's see whether it works. And to see whether it works, we can use localhost because this is going through Docker desktop and it is being forwarded to the cluster. Let's see whether it works. So the address is localhost without ports. It's on port 80. And there we are, right? This is the application that was just deployed in this newly created cluster. It all works, it's all peachy, and it's lightning fast. I must repeat this over and over and over again. This is the fastest local Kubernetes cluster, or Kubernetes cluster meant for temporary testing purposes or something like that. Now, I spoke a lot about speed. Let's put that to the test. Is it really that fast? Is it faster than Kind, which I told you to use only a few videos ago? Let's do a speed comparison, but before we do that, let me delete the cluster we just created, and we're going to start over and do a speed test and see who is faster, Kind or K3d. Both of them are very similar. Oh, I made a typo. K3d cluster, delete my cluster. There we are. Okay, speed test is coming next. We're going to test a couple of combinations. This will be speed test between Kind and K3d. They serve similar, if not the same purpose. They are very similar in architecture. They are all Kubernetes clusters running inside containers. And we're going to see who is faster, because let me tell you in advance, most of the other things, no, actually that's not true. There are differences, but let's see about speed. Who is the fastest one? And we're going to start with K3d. Actually, let me explain. We're going to start with a single node cluster, and then we're going to see whether multi-node cluster is any different, and a couple of tests. Anyways, to create a cluster with K3d, we're going to do K3d cluster, create, and then my cluster, and I'm going to time this. You will see a timer running around that will show how fast it is. Now it is pulling the image. This might be the thing that takes the longest. It's there, creating load balancer, pulling image. This is like being a commentator on a soccer match or baseball match or whatever you're watching. But anyways, I will not comment much on the time right now, because in post-production I will know how much exactly it took. But there it is. That's how much it takes to create a cluster in K3d. I think it's around 20-30 seconds, something like that. Now let's destroy it and see how we can do the same thing with Kind. K3d cluster, delete my cluster, and it's gone. Now let's see how much time it takes to create a cluster with Kind. And the command is Kind create cluster -- name my cluster. Let's call it the same as the previous one. And this will, I did it before, I already know the results. It will take a while. So I'm going to fast forward to the end of the process. Now, I cannot say how much exactly it took because I did not time it, but I will put, you should see the timing on the top of both K3d and Kind. But even without knowing exact timing, K3d was faster than Kind. Now, I wanted to do a speed comparison with creating a multi-node cluster, but I will not bore you with that because I know the results in advance. Kind is much slower than K3d with a single node cluster, and if we increase the number of nodes, it just gets worse. It is comparatively faster and faster the more nodes we have. So if speed matters, and it should, because you want to create a cluster like this, you don't want to wait until those things happen, K3d is a winner. Here's what's going on. K3s, not K3d, we are going to get to K3d later. K3s removed all the things that are not necessarily necessary. Rancher, the company behind, or the community behind K3s, removed legacy stuff from Kubernetes. They removed also alpha releases of stuff, non-default things, in-tree plugins, and so on and so forth. So they shrinked Kubernetes drastically by removing things that you're most likely not using. But remember that I said most likely. That will become important later. For now, let's say that you're probably not using those things. Also, they replaced some Kubernetes components with lighter versions of the same things. For example, instead of using etcd, which is in almost every Kubernetes cluster, it is using SQLite. And all those things are important if you're running in IoT or on the edge, because you want it to be as small as possible, because those things do not have a lot of memory and CPU and whatsoever. And that's what makes K3d awesome, because K3d is K3s in a container, and it's absolutely awesome not to have to waste more memory and CPU than necessary on our laptops, because we want to save the resources on our laptops for other things, whatever those other things are. But hey, it would be nice to run a Kubernetes cluster that wastes no resources, that is tiny, tiny, tiny. So resource usage and speed of K3d is a huge bonus. It's a huge benefit that makes it better than Kind, and definitely better than Docker Desktop, Kubernetes mode, and infinitely better than Minikube. It is fast and it is tiny, but that comes at a cost which for you might or might not be important. And that cost, the price, is Kubernetes compliance. I mean, K3s is compliant with most of the things or everything that you are using, probably. But it is not a fully compliant Kubernetes cluster that is doing everything that Kubernetes does. It's just doing most of the things that everybody needs. So if you need a Kubernetes cluster running locally or temporary test environments, and that cluster to be compliant or closer to be compliant with whatever you're running in production, Kind is a better option. K3d might not be the best option, but for majority of us, me included, most of the time, not always, most of the time that does not matter, because locally I want to run my application, and my application is most of the time working quite well in K3d, and at the same time I'm faster and I save resources. But if you want to test, let's say, moving from one Kubernetes version to another locally or in a temporary environment, you might want to use Kind for that if you want to be closer to production. For everything else, K3d is a better option as long as you're not using legacy resources and alpha releases. But you shouldn't be using alpha releases anyways, except if it's to try it out and see how it works. So is K3d better than Minikube and Docker Desktop, the one with Kubernetes enabled? Yes, definitely. It is a better option to run Kubernetes locally, and it is a better option for the same reasons why Kind is a better option. So if K3d and Kind are both better than Minikube and Docker Desktop, probably, for running clusters locally, then the question is which one should you use of the two? And I say K3d because it's faster and it uses less resources, except if you're using some things that are not available in K3s. So try it out with your applications. If everything works fine, you're golden. If it doesn't, if you're using alpha release of something, if you're on the cutting edge of Kubernetes, then Kind might be a better option. But there is a thing you should be aware of. K3d uses traffic, and that might or might not be a problem. If you're using ingress without specifying which ingress you want, then that will work. If you're using some specific ingress, if you need Nginx ingress and you absolutely need it, I mean, most people don't, you don't care locally whether, and anyways, if you need a specific ingress, you need to disable traffic and install the ingress you need. Otherwise, for majority of people, if you just want to see traffic coming in, then traffic should be okay, as long as your manifests are not specifying explicitly that it needs to be some specific ingress controller. That's it. Thank you for watching. You know what to do. Hit the like button, subscribe to the channel, do all the stuff that you normally do in YouTube. Keep sending me your suggestions. K3d was suggested in a ton of comments. That's why I made this video. So keep your suggestions coming and I will keep making videos based on your suggestions. That's more fun for me and for you than me trying to figure out what might be the subjects you're interested in. So keep them coming. See you next time. Cheers.